Welcome back to Dr. Liu's VCE Chemistry channel. Today, we are breaking down protein and vitamins from the 2018 VCE Chemistry exam. As I go through this, please feel free to correct me if you find any mistakes. All feedback from teachers, parents, and students is greatly appreciated. Protein P is naturally a molecular coil. When mixed with citric acid, it denatures, forming solid lumps. This denaturation is caused by the acid's disruption of the hydrogen bonds that maintain the secondary structure of the protein. The decrease in pH also leads to the protonation of certain side groups. Option A, incorrect. Isomers must have the same molecular formula, but different structures. Vitamin D2, ergocalciferol, is C28H44O, and vitamin D3, cholecalciferol, is C27H44O. Since their formulas are different, they are related compounds but not isomers. Option B, correct. Vitamin D is a fat-soluble vitamin, along with A, E, and K. Due to its nonpolar structure, it is readily dissolved and stored long-term in the body's adipose, fatty tissue and the liver. Option C, incorrect. While vitamin D has one polar hydroxyl, OH, group, the rest of the molecule is a large, nonpolar hydrocarbon chain and ring structure. This extensive nonpolar region makes the entire molecule overwhelmingly fat-soluble, nonpolar, rather than water-soluble. Option D, incorrect. Vitamin D is unique because the body can manufacture it. Vitamin D3 is synthesized in the skin when exposed to ultraviolet B, UVB, radiation from the sun. It is considered an essential nutrient only when there is insufficient sun exposure. The definition of an alpha-amino acid requires both the amino and carboxy groups to be bonded to the same alpha carbon. Consequently, a standard dipeptide bond must be formed exclusively between the alpha COOH of the first residue and the alpha NH of the second. Option C is the correct dipeptide because it is the only structure that correctly uses this alpha COOH to alpha NH. Options B and D are incorrect, as they contain a beta amino acid residue, which is characterized by the NH2 and COOH groups being separated by two carbon atoms. Option A is incorrect due to its structure being interpreted as a non-standard isopeptide bond, where a side chain COOH group is used instead of the necessary alpha COOH group. There are 4 optical isomers of ascorbic acid. Only one of these, L-Ascorbic acid, vitamin C, is active in the human body. Vitamin C is essential in the human diet and has many functions. One of its functions is as a coenzyme in the production of the protein collagen. During the synthesis of collagen, vitamin C acts as an electron donor. Collagen is important in the body. A lack of collagen results in a condition called scurvy. Proline is unique. It is an unusual alpha-amino acid because its side chain forms a 5-membered ring that includes the nitrogen atom of the amino group. This makes it a secondary amine within the peptide backbone, unlike most other amino acids, which are primary amines. The Zwitterion contains positive and negative charges simultaneously. The overall molecule is neutral, yet includes both positive and negative charges simultaneously. The amino group gains a proton to become positively charged. In proline, the ringed nitrogen becomes NH2+. The carboxyl group loses a proton to become negatively charged, COO. Cofactor, vitamin C binds to the inactive enzyme, causing a conformational change that properly shapes the active site, thereby activating the enzyme for substrate binding and catalysis. Redox cycling. Ascorbic acid is oxidized, loses electrons, during the reaction, but is then reformed, reduced, in a subsequent step. This allows it to act as an electron carrier. Reductant role. It functions specifically as a reductant by donating electrons to the enzyme substrate complex, which is essential for facilitating the necessary chemical transformation, the reaction. Optical isomers are non-superimposable mirror image structures that exhibit opposite optical activity, meaning they rotate the plane of polarized light by an equal amount, but in opposite directions. Enzyme specificity. Enzymes have a highly specific shape or spatial geometry at their active site. Lock and key induced fit. A molecule, either a substrate or a coenzyme like vitamin C, must have a complementary shape to successfully bind to that active site. Chirality of optical isomerism is key, because optical isomers, enantiomers, are non-superimposable mirror images. They present their functional groups and atoms in a different 3D spatial arrangement. Biological discrimination. The enzyme is specifically evolved to match only one arrangement, in this case, L-ascorbic acid. The mirror image, D-ascorbic acid, cannot bind effectively because its spatial arrangement does not align with the binding pockets on the enzyme's surface. Unsaturated fats are structurally distinct from saturated fats because they contain carbon-carbon double bonds rather than just single carbon-carbon bonds. This feature renders unsaturated fats highly reactive and prone to oxidation, a process where they can easily generate and propagate free radicals in the presence of oxygen. Vitamin C, ascorbic acid, inhibits this chain reactivity, acting as an antioxidant to stabilize the fats. Alpha-dipeptide structure, MCQ 28, alpha amino acids require NH2 and COOH on the same alpha carbon. The peptide bond must link an alpha carboxyl, COOH, to an alpha amino, NH2, Zwitterion of proline, SAQ4A, an unusual alpha amino acid forming a ring. Its Zwitterion has positive NH2+ and negative COO charges. Protein denaturation, SAQ4B, adding citric acid, decreasing pH, causes the protein coil to form solid lumps, vitamin D, and isomer specificity, MCQ7, SAQ4C, vitamin D, MCQ7 a fat-soluble vitamin stored in fatty tissue. It can be synthesized in the skin by the body, not always essential. L-Ascorbic Acid Activity, SAQ4C only the L-isomer works, because the enzyme's active site has a specific spatial geometry that matches only the L-isomer's 3D arrangement. Optical isomers are non-superimposable mirror images with opposite optical activity. Vitamin C, coenzyme and antioxidant, SAQ4B, SAQ4D. Coenzyme activates the enzyme by changing the active site shape and functions as a reductant, electron donor, in collagen synthesis. Antioxidant protects unsaturated fats, which have reactive C=C bonds, from oxidation and free radical damage. Vitamin C inhibits this chain reaction. If you need my help, please add me on WeChat or WhatsApp and send me an email. Thanks for your attention. Please note Dr. Liu's VCE Physics channel, Dr. Liu's VCE Chemistry channel, and Dr. Liu's VCE Biology channel.